Now, how are fingerprints created? Our skin is not smooth. It's covered in this minute pattern of ridges, and these are called friction ridges. And these are not accidental. These are very important to us. These friction ridges enable our hands to hold up objects. So if I didn't have friction ridges, I wouldn't be able to hold up this water bottle like this. It would drop out of my hand immediately. It's the pattern of the friction ridges that gives the pattern of the fingerprints. But what is a fingerprint actually made of? The material that is deposited is the excretion from the glands which are just below your skin. And these glands excrete a cocktail of natural chemicals: salts, fats, amino acids, proteins, and water. And it's the deposit of these on the surface of some other object that creates the fingerprint. Now let's compare fingerprints to DNA. With DNA technology, we can statistically calculate that no two people have the same DNA. Or, to be correct, we can statistically calculate that the likelihood of two people having the same DNA is minute and vanishingly small. Except, of course, for identical twins, as we have discussed in the DNA lecture. Fingerprinting is not quite the same, even though the early experts on fingerprinting did do statistical calculations. It's essentially experience. In more than a century of fingerprinting, no two people have been found to have the same fingerprints. Even identical twins do not have the same fingerprints. Their fingerprints may be very similar, but they are not necessarily identical. The reason that identical twins can have different fingerprints is that identical twins are identical at the moment of conception. Everything that happens after conception is not necessarily identical and can be different. And fingerprints, of course, are formed later. So the first principle of fingerprinting is about difference. And the first principle is that no two fingers have the same prints, including identical twins. That's why when you're fingerprinted, they take all 10 prints. The second principle of fingerprinting, which was pointed out by Mark Twain, of course, is that fingerprints do not change during a lifetime. So Mark Twain used the phrase, "from the cradle to the grave." In fact, fingerprints form before you are in your cradle, before you're born, but obviously that's not of great forensic use. And fingerprints remain after you're in your grave, after you're dead. In fact, fingerprints will survive as long as your skin survives. So even when your internal tissues are liquefying, you can still give fingerprints. Now, do fingerprints change? Fingerprints of themselves do not change, but fingerprints can be changed. So here is an example of the famous American gangster. He was #1 most wanted, John Dillinger. And he knew the dangers of his fingerprints giving him away, so he attempted to destroy his fingerprints using concentrated acid. As you can see, he didn't succeed. Nevertheless, there are ways to get rid of your fingerprints. And one way is if you're taking this anti-cancer drug, capecitabine. So there was a gentleman who was taking capecitabine because he was in remission from cancer. It's an anti-cancer drug. But he was in remission, and he traveled to the United States to visit friends and relatives. Now, when you enter the United States, you are fingerprinted. But one of the side effects of this drug is so-called hand and foot syndrome, which includes swelling of the tissues of the hand and foot. And his fingers had swelled so that his fingerprints had become indistinct. And the officers at the passport control could not obtain his fingerprints. So this unfortunate gentleman was held for 4 hours until the immigration guys were convinced of his situation. So if you are taking this drug and you plan to travel to the United States, do make sure that you have a letter from your physician with you. I happen to know someone who has no fingerprint on one of her fingers. And this is one of my nieces. And when she was very small, she decided to investigate a rice cooker which was on. And she investigated it by putting her finger in the rice cooker. So the end of that finger was severely burned. And what amazes me is how someone so small can make so much noise. Well, of course, we took her to the doctor and her finger was treated and it's all fine now, but even to this day, she has no fingerprint on that finger. So yes, it is possible to remove your fingerprints, but this is a particularly painful way to do it. And in fact, showing up at immigration with no fingerprints at all is more suspicious than showing up with fingerprints. Now, fingerprints are being increasingly used in security and other areas to identify people, and therefore it's obvious that criminals are going to try to find ways to get around fingerprinting. And one way that is being used is skin grafting. And this is just like a skin transplant. A doctor removes the skin from the end of the finger and grafts on skin from another part of the body, such as the feet. So this is not eliminating the fingerprint, but is changing the fingerprint. The old fingerprint disappears, and the new fingerprint will be from the friction ridges from whatever part of the body was used, such as the soles of the feet. So here's an example from a few years ago, 2005, when a man with a criminal record called Mark George entered the United States from Mexico. Now, Mr. George, because of his criminal record, did not want to be recognized at the border. He knew he would be fingerprinted, and therefore he went in for this skin graft procedure. He got a doctor to graft skin from his feet onto his fingers. The mistake he made was to try to re-enter the United States before his feet had healed up properly, and his limping gave him away, and he was identified and arrested. The doctor who carried out this procedure, a man called Jose Covarrubias, was tracked down. He was living in Harrisburg, Pennsylvania. He was tracked down a few years later, and he was charged and ultimately sentenced to 18 months in prison. It's a relatively short sentence, and that is because it could only be proved that Dr. Covarrubias had carried out this medical skin graft procedure, and there was no evidence that Dr. Covarrubias had been involved in any of Mark George's other activities. But this is going to be an increasing problem, as the authorities rely on fingerprints to identify people. Criminals will look for ways to get around that technology. The third principle is that the patterns can be classified, and this of course goes back to the work of Galton that we mentioned. The small features present in fingerprinting can be described in different terms, and you can see some of the terms here on this slide. And looking at them, you can see that some of the terms are clearly geographically inspired, and some appear to be inspired by the railways. In addition to these small features, the bigger pattern of the fingerprint can also be classified. And here you can see some of the classifications that fingerprint examiners use. Now sometimes fingerprints are visible. Juan Vukotic, for instance, the fingerprint that convicted Francesca Rojas was a visible fingerprint because it was in blood. But many fingerprints are not visible to the naked eye, and these are referred to as latent fingerprints. And latent fingerprints require some artificial means to make them visible, and typically they require treatment with a chemical for chemical visualization. So in order to understand chemical visualization, we need to remember what fingerprints are made of: metal salts, amino acids and proteins, fats, and water. Though of course the water is not going to last very long because that's going to evaporate. The simplest way to visualize fingerprints is to use a dusting powder. And this is not strictly a chemical method, it's simply the physical adhesion of the powder to the fingerprint. There are various dusting powders available, but the general idea is that you choose a dusting powder that will contrast with the background. So if you're looking for fingerprints on a white surface, then you can use a black powder like carbon black. If you're looking for fingerprints on a dark surface, then you can use a light powder like aluminium. The powder can then be lifted off onto tape and photographed and preserved. There are also various chemical reagents available. For instance, the object can be sprayed with ninhydrin, which reacts with the amino acids present and makes the latent fingerprint visual. Other chemicals are like iodine or silver nitrate. There are also physics-based methods, for instance using a laser to get laser fluorescence, which can be done alone or in combination with a dye. One of the most effective methods is the so-called fuming cyanoacrylate method. And that sounds very technological and sophisticated until you realize that cyanoacrylate is just super glue. And this is a technique that was discovered accidentally by two Japanese police officers. And they were using superglue to fix some objects down when they realized that the superglue was causing fingerprints to show up. The mechanism is not clear. Something in the fingerprint, possibly the amino groups of the amino acids, is inducing polymerization of the cyanoacrylate molecules in the superglue vapor. But what is happening is that the superglue is depositing on the fingerprinting, making it visible. So nowadays, it's not done by accident. There are specific devices, fume chambers. Some of these can be quite small for small objects, but you can get commercial superglue fuming chambers big enough for rifles. You can fume an entire car in order to find fingerprints. So it's proved to be a very useful method. With fingerprinting, there's still a need for improved methods for visualization, particularly for some of the surfaces where it's difficult to do. There's another aspect of fingerprinting is the use of electronic databases. Fingerprint databases started over 100 years ago, but those were on card, and that required a fingerprint examiner to go through them one by one. Those databases are now electronic, and computers can go through finding matches. But we have to be careful. When an electronic database searches through fingerprints, it's not looking for perfect matches, it's looking for close matches. And a search of a database will give a number of close matches, a number of hits. The final judgment then comes from a human fingerprint examiner. And usually that is very reliable. But as with every human activity, it can go wrong. It went spectacularly wrong back in 2004 in the case of Brandon Mayfield. Brandon Mayfield is an attorney in the state of Oregon in the USA. And he was detained as a material witness in the Madrid train bombings. So back in 2004, terrorists planted bombs on a number of commuter trains in the Spanish capital Madrid. And when those bombs exploded, 191 people were killed. This was in the run-up to the Spanish general election, and the bombs almost certainly influenced who became prime minister after that election. On a bomb fragment, a partial fingerprint was found. When that partial fingerprint was run through electronic databases, it was found to be a partial match to Brandon Mayfield. And this is why Mr. Mayfield was detained. However, there's an immediate problem with this idea in that the bombs were planted in Spain, and Mr. Mayfield lives in Oregon, which is an awfully long way away, and there was no actual evidence that Mr. Mayfield had traveled to Spain. But how did his fingerprint get on the bomb? And the answer is, it didn't. It was only a partial match. It wasn't a perfect match. The Spanish discovered that the fingerprint on the bomb was a perfect match to a man called Unane Daoud. And he is their chief suspect in this case. So this case of Brandon Mayfield and the fingerprint reminds us of what Edmund Locard said, that physical evidence cannot be wrong. Only human failure can diminish its value.